All right, ladies and gentlemen, our next presenters are Gal Cohen, Samin Jahal, and Philip Kazal. Probably slaughtering every one of your names, and I'm going to apologize ahead of time. Their presentation, Scratchable Devices, which is a user-friendly programming for household appliances. Ladies and gentlemen.
Hi. So let's say I was teaching you guys how to control the devices in your house. Currently, I would have to give you guys a complicated menu system, and you have to work through a series of just unintuitive tasks to complete something meaningful. And that's not the right approach. That's not the direction we want to head, and we think we have a solution for that. So our thing's called Scratchable Devices. We're trying to say that we're advocating user-friendly programming for household devices. We're saying that programming is the best approach to control your household because you'll be able to do a lot more things that you normally could not do before. You could do them faster, and you'll be able to learn a lot of different things faster because you have a single platform, a single place where all your devices are being controlled from. And this is much better than the traditional interfaces like menus that I just mentioned. So this is what we're going to be talking about today. What the current state of household control is, home automation, just regular control, how we mean to achieve that through a program called Scratch, a programming language called Scratch, and enhancements we made to Scratch, and the programming primitives we're going to show you, and we're going to include some demos to just prove to you that, or show you that this is right. And now I'll hand it over to Paul.
So the current state of household device control is, well, first, you've got a lot of different devices, and they're all operated in different ways, button interfaces and such, and they're very difficult to control. Take, for example, this alarm clock. It's got all these buttons, and we have absolutely no idea what they do. And even if we were to figure out how to set the time on this particular alarm clock, it wouldn't help us figure out any other alarm clock because they're all complicated, even though they're all doing basically the same thing. So button interfaces are very different and complicated for each device.
Buttons can also be very unintuitive. Take, for example, that up button over there, which from its label, the user might actually not know what the button actually does. But on the right over here, we have the program that controls that button controls. And although it may look a little bit complicated, but with a little familiarity with programming, the user might be able to deduce what that button actually does.
So another form of home device control is home automation. Now, home automation has the same problem. There's no standards. You have all these different companies, and they all have different softwares with different menu interfaces that are complicated and difficult to navigate and actually give you only limited control. So our solution to this is programming. Programming allows you to control the device's actual logic instead of just the parameters given by the buttons. And it allows you for a unified interface across all the devices. So if you can program one device, you can apply that knowledge to program your next device. So you're probably thinking, is programming really hard? Well, I guess it is most of the time, but we found the perfect language for this, which is designed for novice programmers, and that's Scratch.
So Scratch is a programming language developed by MIT. It's a graphical drag-and-drop language. That means there's no typing involved to write your programs. And it's used to teach programming to people of all ages, from kindergarten all the way up to the university level. We're going to show you a little demo of Scratch.
So this is the Scratch environment. On the far left, if you guys aren't familiar with it already, on the far left are different blocks that are available to you. And on top right there are different types of tags. So you can these are controllers, these are operators. There's a lot of different blocks that are available to you. In the middle is the scripting area where you drag these blocks into, and you build up scripts using these blocks. And on the right, or your right, there's a sprite. A sprite is sort of like an object in Scratch. You can move it around, and this scripting area applies only to that sprite. If you add a new sprite, and we're going to add a random sprite. This has a new scripting area. So if you have more blocks for this, if you have a new script for this sprite, then it's not going to affect the other sprite's function, unless you want to. So we're going to show you a quick demo of what you can do with this programming language. We're going to say, continually pull to see if the mouse is currently down. And if the mouse is down, then we're going to have the sprite point towards the mouse pointer and move a certain amount of spaces. And every time you put your mouse down, the sprite follows you around. So using 3 lines of code, you can do something that would be much more complicated in another language. So this kind of proves or shows you how Scratch can be powerful in certain ways.
Okay, so now we're going to talk to you about programming primitives that we added to Scratch to have it interface with our devices. So in Scratch, everything is object-centered. So you have your sprites and blocks. Those blocks that are in the sprite scripting area correspond only to that device or that sprite. So that means that the same blocks that control the yobo do not control the cat, and same for the cat. Its blocks do not control the yobo. So in our prototype, we have each device as a sprite in Scratch. So when you go to programming in Scratch, you'll have a turn-on block that will only correspond to the fan, and a turn-on block that will only correspond to the lamp, and these two turn-on blocks won't interfere with each other.
And since all the sprites have, all the devices have their own sprites, you can they also internally keep their state. So you can poll to see if is the fan on, is the lamp on, and these Boolean operators will let you do a lot of cool things, like this script right here. This is a clapper. We're continuously polling to see if it's loud, if there's a loud noise in the area, and if it is, then toggle the state of the lamp. If the lamp is on, turn it off. Otherwise, turn it on. And if we show this to you, could you let's all clap together on 3. 1, 2, 3. See, there's a lot of different. We all clapped at different times. You can also set a threshold to that. So if it's loud past a certain limit, then and it's telling me I'm really loud, then I could just make it higher. So my voice doesn't affect the turning on and off of the lamp.
It's cheating. He's controlling it.
So device state is a type of input in Scratch that we made. It's local to the device, so only each device can see its own state or query its own state. Other sensors in Scratch are, inputs in Scratch are sensors, if you can see on the far left. And that provides data that is global to any device. So any device can use this data and interact with it. Because state is kept in Scratch, outputs are considered state changes internal to the device. So whenever the device has a state change inside of itself, it's broadcasted to the device, and that device can execute appropriate actions. So since device state is kept within the sprite, there's no way of really broadcasting that out to the network. But in Scratch, there's a function called broadcast, which allows a user to define a message, and any sprite in Scratch can broadcast a message, and any sprite in Scratch can listen for a broadcast. So over here, we have a doorbell broadcasting the doorbell message when it feels that its button's pressed, and a security camera that is listening for that message, and when it receives that message, it's going to take a picture, presumably of the person's face in front of the door.
So just like any other programming language, Scratch has the same types of primitives, such as loops, if statements, you have relational and logic operators, you have math operators, and you have variables that you can set or increment.
And to finish it off, we're going to show you some cool demos that we've come up with. Remember the clapper that we just did before? That was for the lamp, and I'm going to show you that to have a clapper for the fan is extremely simple, and it's the exact same code. It's just in the scripting area of the fan now. And I'm setting a threshold. Phil's setting a threshold to go above a certain level, because it might be a little loud. And then if we all clap again, ready? 1, 2, 3. It turns on. It doesn't have to be that loud. You can turn it off. It's fine. So yeah, transferring from controlling one device to another device is extremely simple, and through the same interface. So you don't have to get used to multiple different interfaces.
So our second example is a vacation intruder alert. Let's say you're going on vacation and you want us to have something to protect your home. You can have the webcam or some kind of security camera in your home detect the motion. You can program it to detect the motion of someone in your home and turn off some kind of alarm, play a sound, flash the lights, or whatever else you want it to do.
Call the police.
Sure. Okay, so let's say I'm an intruder, walk in front of the camera.
And because we can define the inputs, it doesn't have to be the computer that the intruder walks in front of. We can make it walk in front of like a camera and send that message over to Scratch. So what we're trying to advocate is that programming will help you do a lot more with your device than you could before. For example, this script, it checks if the coffee maker's on. This is the script for the coffee maker. And after 5 minutes, it'll alert you saying, it's playing a song saying the coffee's done. And something you couldn't do before.
We're also showing you that you can take the same daily tasks that would take you a long time to do, like setting your alarm clock, and now you can do it instantly with blocks that just set the time and date and the month.
And with this unified interface, programming allows you to control other devices sooner. So the programming that you learn for one device is not only for that device, it's for every device that you ever control. And you can just transfer that knowledge from device to device. Thank you.
Question?
Any questions for the guys?
It's interesting, but I'm always resistant for more to learn more languages. I learned so many languages and I forgot them already. So I am interested in how that thing gets to the land. How much intelligence the land has to be get there.
This is a normal $5 lamp.
Yeah. So the lamp right now it's a prototype, so it has an Arduino inside of it, and Arduinos are pretty expensive, But the functions for a lamp say is not that much more expensive. So we could actually get a cheaper microcontroller, say a $1 or $2 microcontroller, and put inside the lamp, and it would function the exact same way.
And there are some standard interfaces how you talk to the lamp.
Yeah.
You actually transfer the code compiled from the language to the lamp.
It's actually, the code doesn't get compiled, so this is all happening in real time, sort of. So Scratch communicates over internet sockets, and it's what it does, it broadcasts messages and other variables and state changes and everything over those sockets automatically. And we have a program that's capturing those and sending it over to the devices.
How is it actually sent to the device?
It's using an XP.
I think the value here, if you make this work with existing control systems like say X10 or something like that, rather than reinvent the wheel, then I think it's pretty exciting actually. Does this run off of say Android or anything like that, or do you have to use a PC? Right?
Yeah. So Scratch on Android, there's actually a couple projects trying to be ported to Android there right now. They're on Google Code. They're in active development, but there hasn't been an official one yet. Right now, it's only for PC.
Yeah, I can see the value because everybody reinvents this. I've seen this so many times, but it's always someone's favorite method to do it. But I think if you've got a really nice, easy to program system that, especially if you go to something like Android, and you can just forget about the hardware, use existing systems, so you don't have to go down that torturous path. And I think you've got a really nice idea here.
Yeah, you claim that it's easier for users. Did you actually test it with users to back up your claim?
No, we plan on testing it in the future. We were working sort of on the prototype a little bit and getting all the primitives and everything worked up. And we plan on doing user study where you compare traditional interfaces to programming interfaces and see how they match up with users.
Although the language itself, Scratch, has been shown to be pretty effective at teaching people of all ages to program. They actually use it for non-introductory courses to computer science, and they use it in kindergartens, high schools, middle schools.
So when you guys are successful, can you have the devices come pre-programmed so that when I get it on to program into?
Yeah, so what we envision sort of is that when you buy a device, you plug it into your computer, everything on the device is programmed. So once you plug it into your computer, you'll be able to download the program that controls the entire device. And you can play around with that. But, and if you want to add scripts to it, yeah, you can, we envision that you can add scripts to it too. So these devices would function as they normally do, but with their logic and everything exposed to the user.
And you can also define blocks. So the scripts we wrote, we can put into like one different block. And you drag that one block over and click on it, and it'll do everything that entire big script did. So we could define some already, cool tasks. And if you wanted, you could go into the blocks and change it. Scratch is pretty good with that.
Do you guys plan on targeting this more towards a do-it-yourself community, or do you plan on having a plethora of devices which you sell?
We're planning to expand past fan lamp. What else? We have an alarm clock. We have a coffee maker in the works.
Coffee maker.
And we're going to expand to a whole suite of devices sooner or later. But it's probably going to be towards the do-it-yourself community. The idea was to teach people how to program. And, it's hopefully going to go down that path.
Any further questions? All right, thank you again, guys. We appreciate it.